Hi all, welcome to this video. Today I will show you how we can detect lane from an image of a road which has lane lines defined on it. This is a basic tutorial of lane detection which leads to self-driving car using artificial intelligence. So stay tuned. Before jumping on how we can detect lane, let's discuss some concept on how an object seen by a human eyes and how to represent an image in a digital format. As we know, when light is reflected from an object, it is perceived by our eyes and hit the light sensitive tissue layer at the back of our eyes, also called retina. The retina is comprised of special cells called photoreceptors which turns the light into electric signals. These electric signals are transmitted to the brain by the optic nerve. The brain turns this signal into an image of the object and its color in the visual cortex, giving the capability to see and understand the image. Our eye can only understand a range of wavelength of light known as visible spectrum, which ranges from 380 nanometer to 700 nanometer or 400 terahertz to 790 terahertz in terms of frequency. The rest of the wavelength of light is invisible to us and also called electromagnetic spectrum. When an image is stored digitally, it is stored as a matrix of pixels which have its color information. For a grayscale image, we can think of a matrix which have its color information as its value in 256 tones ranging from 0 to 255, where 0 represents pure black and 255 representing pure white, and anything between it is a blend of white and black if the value is reduced and lighter if the value is increased. As we know, electronic devices only understands 0 and 1, and these pixel values are stored in binary format of 8-bit, which can be represented as 8 zeros for the value of 0 and 8 ones for the value of 255. With 8 zeros, the device will understand the color black, and with 8 ones, the device will understand the white color. For color images, the pixel will have 3 values, and you may think 3 matrices of color values, each ranging from 0 to 255 in binary format, representing red, green and blue, popularly known as RGB. So, a typical pixel comprises of 24 bits having 8 bits of each color. Also, the most interesting thing is that you can achieve any color by mixing these 3 colors in different values. So, we can represent any color value of any image pixel with these 3 color matrices. Now, as we have understood how a color and a grayscale image is stored digitally, we are now ready to manipulate an image of a road which has defined lanes and detect it based on the color that is white or close to white. Now let's start and make our hand dirty with some code. I have downloaded an image of a road with lane lines marked on it from the web, and let's work upon it. I have opened a new Jupyter notebook, and let's start with importing the required libraries. So let's import matplotlib.image as img, and also import matplotlib.pyplot as plt. Let's import the numpy library as np, and also import the OpenCV library, which is a very useful library for image manipulation, and we will import the sys library, and let's execute it. Next, let's load our image using the matplotlib.image library. So img dot read, and provide the path. As the image is in the same directory, we have to just type in the name of the image, and let's assign it to a variable, say color road image. Now as we have loaded this image, let's plot this image using the pyplot. So plt.imshow, give the argument as the image variable, and we can see the color image I have downloaded from web, and it has roads with the lane lines in it. So we are going to detect the lane lines of these roads. So first, let's see the shape of this image matrix. So color road image dot shape, and we can see it is 350 by 960 as plotted by the pyplot library, and also we can see 3 as it is a color image, and as we discussed, there will be values for red, green and blue, the RGB matrices. So it is 350 by 960 by 3. Now let's try to convert this image into a grayscale image. So we will use a variable gray road image and assign and use the OpenCV library to convert the image to grayscale. So we give the color image as the argument and the parameter as cv2 dot color underscore bgr2 gray, and let's execute it. Now let's see the image by plotting it using plt. So plt dot imshow gray road image and cmap as gray, and let's execute. And you can see we have successfully converted the color image into grayscale. Now let's see the shape of the grayscale image. So let's type the variable gray road image dot shape, execute it, and we see that it is 350 by 960. So now it has become a two-dimensional matrix. So if you check the previous value, it was 350 by 960 by 3 for the 3 colors. But now in grayscale, since the color is only black to white, so it has only having 2 dimensions, 350 by 960 unchanged. Also let's see the values within this matrix. So gray road image and execute it, and you can see the values are within 0 to 255. So let's change the print option, np.set print options threshold sys dot max size, and let's execute this cell, and took some time to bring all the values, and we can see all the values are within that range 0 to 255. So let's continue with our lane detection. So let's copy this grayscale image. So we take another variable, copy gray image, and use the np copy function and give gray road image as an argument. Let's take the copy gray image variable and try to replace all the values which are not white or near to white. So we take the array and just check with this shorthand syntax to find out any value less than 200 and set it to 0. I am considering the values from 200 to 255 as the range of white values, and any other values below that will be set to 0, that is black. So we will keep only the pixels of the image which have values ranging from 200 to 255. So let's execute this code and let's display the resultant image. So plt.imshow and provide the copy gray image as an argument, and cmap equal to gray. So now you can see all the lanes with white color is been detected in this image. So we can see that other objects and everything has been turned to black. So this is the first step you can use to detect with your camera that what are the lane lines of the road, and maybe you can calculate that and try to put your vehicle in the middle of the lanes. This can be also done on a video, so there will be a continuous detection of the lane lines and maybe used to detect the lane lines in a moving car. Now let's do the same operation on the color image as we have done on grayscale. So let's make a copy of the color image, copy color image, and use np.copy and take the variable color road image. And then let's take this variable copy color image and use the same kind of syntax. So we again copy this variable and we provide the all rows, all columns, and the color matrix at the position 0 and check if it is less than 200. Same thing we will do with the second color matrix, and next we do with the third one, and set the value to 0 whichever value is less than 200 and execute this. So there is a syntax error. Okay, so I missed the bracket here. So let's execute this and let's plot the color image. So copy color image and execute. And we can see we are getting a more or less same kind of a output like the grayscale one. So we can see that we can detect the lines of the road. So let's now try to save the images we have created. So we use the OpenCV library cv2.imWrite, and let's give gray road 1 as the file name and use the variable gray road image. Let's save one of our lane detected image. So I am right, and let's save color road image .jpg and provide the variable color road image. Let's execute this and it returns a true, means the image has been saved successfully in the working directory. So today we learned how to load an image and convert it to grayscale using OpenCV, and how we can see the value and the shape of the matrices into the array of image, and then how to detect the lane from the image using the color of the lane. So that's all I have for this video. Thanks all and stay healthy and safe.